Hello students, I am Azizi, Professor Electronics. In our previous session, we have written a program that is my first counter program, and we have developed a program to run the counter on port 1. Here we can find we have moved the value that is 00H to port 1, and here we can find we have initialized the value of R0 to 00H, and here we have moved the value of R0 to port 1, and here we have written an instruction to increment the value of R0, and here we are calling a delay, and we have calculated the delay in our previous program and it was 130 millisecond, and here we can find another instruction that is jump main. So our program will go back to the main after calling the delay. After the delay routine, that is the 130 millisecond of delay, our program will jump back to the line that is jump main, and it will go back to the main and execute our program continuously. In this session, we will write a new program to run a counter on port 1, and the counter will be incremented by the delay of 1 second. This delay routine will produce approximate timing, but to have accurate time, we'll use timer interrupts, as we'll see in our future programs. So now we'll write another program in which we'll increment the counter by 1 second on port 1, and we will use the RAM location as counter instead of using R0. So let's see how we can write our new program using RAM location. First of all, we'll close this project, close project, and we'll create a new project. Okay. New microvision project, and here we'll assign the name to our new project, that is counter project 1. So here we will write that is counter project _1 and save. Now we'll select the microcontroller, that is 89C51, and here we have 89C51 microcontroller. Okay. Copy startup.a51 to project folder and add file to the project. No. And here we'll go for the target 1. Right click, options for target 1, and here we'll assign the value of the crystal, that is 12 megahertz. So here we will write that is 12.0, and we'll go to the output, and here we'll check this box, that is create hex file. Okay. And now we'll go to the source group and right click, and here we have add new item to source group 1. Okay, add, and we'll select ASM, and we'll assign the name, that is counter project _1, add, and here we have the space to write our new project in assembly language. First we'll give the comments using semicolon, and we'll assign the name, that is 1 second delay counter, and here we will write that is counter _delay _1 second, and now we'll define the variables in our program like this. And here we will write register assignments, and here we can see MCS 51 on chip data memory, and here we can find the general purpose RAM starting from 30H. We'll use the first location of the general purpose RAM, that is 30H, as counter, and here we will assign the name to our hardware location, that is 30H, from general purpose register, and we'll assign the name, that is counter REG. So here we will write counter REG, and to assign the hardware location to this variable, we will use equate, that is EQU. So here we will write that is EQU, and here we will write the hardware address, that is 30H. So here we have assigned the name to 30H location, that is counter REG. We can add more variables as and when required in our program. So here we will close this session. And now we'll write the directives for our compiler, and here we will write program directives, and here we'll direct the compiler to start writing our program from 00H location. So here we will write org 0000H. It means that start writing our program from 000H location. So here we'll assign another comment, that is start writing program from 0 location, and on 00 address we will write the instruction that we would like to execute at reset. So here we will write, that is jump, and here we will assign the routine name, that is initialization routine. So here we will write INIR. INIR is the name of our subroutine. So here we will assign another comment, jump to initialization routine. So we have written on 00H that jump to initialization routine, and now we'll direct the compiler to generate the initialization routine from the 30H, and we'll skip the addresses from 1H to 29H because these addresses are reserved for interrupt vectors. So here we will write, that is org 0030H. Now we'll start writing our initialization routine from 30H, and here we can assign another comment like this, start INI routine from 0030H. So the compiler will start writing our initialization routine from 30H location. So here we will start writing our initialization routine like this, and on 30H location we will start writing our initialization routine like this using colon, and now we will start writing our initialization routine like this, move port 1 comma hash 00H. It means that we want to move the value, that is 00H, to port 1 in initialization. Here we have used the name, that is port 1. We can also assign the name to the port 1 like this. Here we will write port assignments, and here we will assign the name to port 1, that is counter port. So we will write counter port, and we will use equate, that is EQU, and here we will write port 1. So we have assigned the name to port 1, counter port. Now we can replace this port 1 by the name, that is counter port. So we will copy this variable from here, Control C, and we'll paste it here, Control V. As we have assigned the name, that is counter port, to port 1, so the compiler will replace this variable with port 1 whenever it will compile our program. And now we will also initialize our counter register. So here we will write, that is move counter reg, Control C and Control V, comma hash 00H. So here we have initialized our counter register to 00H, and now we'll close the session. And now we'll start writing our main program. And here we'll assign a name to our main program, that is main R with colon. And here we'll move the value of counter reg to counter port. So here we will write, that is move counter port comma counter reg. And now we'll increment the counter reg. INC counter reg, and now we will call a delay routine like this. Call delay underscore r underscore 1 sec is the name of our delay routine. And after calling this delay routine, we'll instruct our program that go back to main routine. So here we will write jump main underscore r. So from this line, our program will jump back to the main routine. So here again we'll close the session, and now we'll write our delay routine. And here we will write that is 1 second delay, and here we will write the name of our delay routine, that is DELY underscore R underscore 1 second with colon, and here we will write the delay routine of approximately 1 second. So how we will write this delay? We will use register bank, that is move R0 comma hash FFH. So we have initialized the value of R0 to FFH, and we will use move R1 comma hash FFH, and if we will initialize the third register, that is R2 to FFH, then we can calculate what will be the value of the delay. Here we can check by using two registers, that is R1 and R2. We have the delay, that is 131 millisecond. So if we will use three registers, then the delay will be, now if we will use three registers by the same value, that is FFH, then what will be the delay? So here we will write 256 into 256 into 256 multiply by 2 exponential minus 6, that is 2 microsecond. So here we can find we will have the approximate delay of 33.554432 seconds, but we want to make a delay of 1 second. So what we will do, we will not use the value, that is 256 for the third register. What will be the value to have the delay of 1 second? We can calculate like this. By using two registers, that is R0 and R1, we will have the delay, that is 131 milliseconds, and we want to have a delay of 1 second. So we will divide the 1 by 131 exponential 3, that is millisecond. So we will have 7.6. It means that we will load the third register, that is R2, by 7 or 8. So we will move the value, that is 8, to the third register, that is R2. So here we will write move R2 comma hash 08H, and now we will write the delay routine of 1 second by decrementing all these three registers like this. DLY underscore 1, and here we will write the decrement instruction, that is decrement jump not 0 R0 comma DLY underscore 1, and now we'll decrement the register, that is R1, and we'll write decrement jump not 0 R1 comma DLY underscore 1, and now we'll decrement the third register, that is R2, like this, decrement jump not 0 R2 comma DLY underscore 1, and here we will write the return instruction from the delay, and we will write RET, and we will close our delay routine. And now we'll write another directive for our compiler, that is end. This end instruction will tell the compiler to compile the program before the end instruction. And before compiling our program, we will check our program once again. Here we have assigned the name, that is counter delay 1 second. And here we have initialized our register, that is 30H, and we have given the name, that is counter register, to the location, that is 30H, the first location of the RAM. And here we have assigned the name to port 1, that is counter port. And here we have written an instruction for compiler that to start writing our program from 00H. And we have written an instruction that is jump to initialization routine on 00H location. And here we have written another directive for the compiler that start writing our initialization routine from 30H. And we have start writing our initialization routine on 30H, that is move counter port 00H, move counter reg 00H. And here we have written our main program, that is main R. In main R we have written that is move counter port, comma counter reg. Now increment the counter reg, call a delay of 1 second and go back to main routine. And whenever our program will come to this line that is called delay routine, it will come here. First it will initialize all these registers, that is R0, R1 and R2, and it will move the value, that is FFH, to R0. And on second line it will move the value FFH to R1. And on third line it will initialize the register R2 with 08H. It means that if we multiply, that is 256 by 8 into 2 microsecond, we will have the delay of approximately 1 second. And then our program will come to delay 1, and here it will decrement the first register, that is R0, up to 256 time. Then it will come to the next line, and again it will decrement R1 one time and will go back to the delay 1. And after decrementing it 256 into 256, if both the registers will be 0, then it will come on the third line and it will decrement the register, that is R2. If the value of register R2 will not be 0, it will go back to delay 1 and execute these lines into 256 time, 256 time and 8 times. So if we will multiply these numbers, we will have approximately delay of 1 second. Now we will compile our program and we will test the result on Proteus. We will check if there is any error in our program. So we will go to the build. OK, build. Here we can check we have 2 errors, that is on line 38 we have undefined symbol, and here we have written move the value, that is FFH, to R0. Here it is not accepting the value, that is FFH. It means that we have to place a 0 here and again 0 here. Now it will move the value, that is FFH, to R0 and R1. Now we will build our program once again, or we will compile our program once again. So here we will go and compile. Here we can check. Now there is no error, no warning. Now we will download the hex file of this project to the microcontroller circuit which we have developed in Proteus. And here we have the microcontroller circuit which we have developed in our previous session. Now we will download the new hex file to the microcontroller. Right click, Properties, go to the folder, and here we can find counter project 1 hex file. OK. Now we will run the simulation and we will observe the delay on port 1. Now we will press the one shot. And we will select the cursors. We will place the first cursor here on the falling edge of port 1.0. Here we have 0 seconds, and we will place the next cursor on rising edge. Here we have 1.05 seconds. It means that the delay which we have calculated in our program is approximately 1 second. The difference is only 0.05 seconds. Now we will check the port, and here we can find the counter is incrementing with a delay of 1 second. The previous delay was 131 milliseconds. In our next session, we will learn that how to interface digital inputs with our microcontroller and how to develop a delay with a different technique, because in this delay routine our program will stay for 1 second in this delay routine and it will not check any other thing in our program which we have written. So we will write a delay that will execute the delay of 1 second, but it will not stay in this delay. Okay, see you in next session with new program. Thanks for watching this semi-language programming course. We hope that you find this course very helpful to learn semi-language programming. If you feel that this course contributes and enhances your embedded system design knowledge, then go ahead and hit like, share and subscribe buttons, and do not forget to press bell icon to stay updated with every new upcoming video from Electroeducators as soon as it goes up. Electroeducators also offers technical consultancy in following fields. For assistance regarding technical problems, projects and any consultancy, feel free to reach out at our email address electroeducators@gmail.com. Okay, see you in next lecture.